Chen Yi.
My name is Shanghai.
Okay, today I'll present you our embedded system project with the robot nurse. And actually we found that we got to do this because there's a lot of patients and there's little time for the nurse to take care of patients with the increased amount of patients. So we decided to create something that can take off the workload of the nurse, which the routine workload, which is the routine that the note for the nurse is actually check the pulse and give the medicine to the patient. So if we take this workload off them, the nurse will have more time to take care of more seriously ill or need more attention patients. So how to check the pulse of the detector is actually we use the LED light and the LDR sensor. So the finger will put on the LDR sensor and the light will shine, and then the spectrum and this LED light actually has contains certain spectrum, and this spectrum is actually affected by the iron in the running in the veins of the finger and in our red blood cells also, in the red blood cells, and affected by it, and this will cause a minor change, and this minor change will be picked up by the LDR, and actually this minor change actually equals to our pulse of the patient.
Okay, my deck will pick up the LDR output voltage, and this voltage is actually like a DC voltage, but there's a ripple because of the heartbeat, and there are constant high frequency noise goes along with it. So what I do is let it pass through a bandpass filter with 1 and 2 Hertz, which is kind of common sense because that's the heartbeat rate. And then the signal is passed through a peak detector. Peak detector is provided by the LabVIEW, and then the timestamp is generated by the LabVIEW peak detector. And by comparing it to consecutive timestamps, the instant heartbeat rate is the detector, and by averaging it, you can get a quite stable heartbeat rate. And then we create apps by speaking and interact with the patient, and you use the ActiveX to control the speaking function, and then once they speak with patient do the action, and after that the servo system controlled by the MyDeck will activate and dispense the medicine to the patients.
So here is a comparison when there's an actual finger in the detector and when there's nothing in between.
I put all the sensors, servo, and PC on the robot and set up the map and the ground station. That is all for the preparation. Firstly, I tell the robot which room to go, and the robot will go there automatically. The autonomous function is implemented by using ROS gmapping and navigation node. It is a quite complicated topic. As you can see, there are a green curve and a red curve. Green curve means the global plan, which gives a rough indication of where robot should go based on the known map. Red curve means a local plan, which includes obstacle avoidance and some other complicated course map function. When robot reaches the destination, it talks to the patient by the text input. I use the Microsoft text-to-speech converter to get the speech, and then use the ActiveX control in the LabVIEW to generate sound. By now, patient has already put in his finger in the sensor. It will take some time to get a stable output as one of the averaging function takes time to sample correctly. Next is to release the medicine. That's the tricky part. For some reason, my DAC can't output 1 millisecond based state change at any of the output pin. So I have to use the my DAC analog output together with an Arduino chip, which is already preloaded with ADC input, convert to 16-bit PWM function to give the correct server output. Then at last, we give the command to go back to where it started. So, or I can give a command to say go to the next room and check the pulse for the next patient. And till now, that will be the end of my video presentation. Thank you for watching this.